All right, get this. We're about to crack open one of the most important laws of the entire universe, and all we're gonna need is a simple party balloon. Seriously, let's dive in. Have you ever just looked at a rocket launch and thought, how in the world does that actually work? I mean, this giant metal tube just blasting off into space? Well, believe it or not, the secret, it's right here, hiding inside this balloon. Okay, so first things first, let's build our very own rocket. Now, this is a super simple experiment, but trust me, the lesson it teaches is absolutely huge. All right, you can even do this at home. Grab a long piece of string and just thread it through a regular drinking straw. Easy enough, right? Then you're going to stretch that string out and tie it up tightly between two things, like two chairs or maybe doorknobs across a hallway. Now for the engine. Blow up a balloon, and this is key, don't tie it off, just pinch it closed. Then use a little tape to stick that balloon right onto the straw. Okay, you ready? Slide the whole thing to one end of the string, take a breath, and let it go. Whoosh! How cool was that? But you know, that first wow is just the beginning. Now we get to ask the really fun question. Why? How did that even happen? And this is where it gets really interesting. I mean, what does a little balloon shooting across a piece of string have to do with the actual laws of physics? You know, the same laws that keep planets in orbit. It sounds like a stretch, but it's really not. Well, the answer comes from one of the all-time heavyweights of science, Sir Isaac Newton. It's all about his famous third law of motion. This is the science behind the speed we just saw. Okay, but before we jump into the law itself, let's just quickly get on the same page about one word: force. What is it? Super simple. It's just a push or a pull. Anything that makes an object speed up, slow down, change direction, or even change its shape. So, that brings us to the big one, the law itself. You've probably heard it before. For every action, there's an equal and opposite reaction. It sounds so simple, right? But those few words, they basically explain how everything in the universe moves. All right, that's a cool sounding theory, but how does it actually connect back to our balloon rocket? Let's break down that launch and see this action and reaction thing, well, in action. So here's exactly what happened. When you let go, the balloon pushed the air out the back. That's the action. But the air didn't just disappear, right? It pushed back on the balloon. That's the reaction. The balloon pushes the air back, and the air pushes the balloon forward. It's this perfect balanced push-pull that sent it flying.
And here's the best part. This isn't just some cute party trick. This exact same idea is what powers some of the most incredible machines on Earth. We're talking from our little balloon all the way up to a massive jumbo jet. Let's take a look at how this law is literally all around us.
Okay, think about something you do without even thinking about it. Walking. Every single step you take, your foot is actually pushing backward on the ground. That's the action.
So what happens next? Well, the ground pushes back on your foot. It pushes forward with the exact same amount of force. And that reaction is what actually moves you forward. Isn't that wild? If the ground didn't push back, you'd just be slipping in place, going nowhere.
All right, let's scale it up, way up. Think about a jet engine on an airplane. It's doing the same thing, just way more powerfully. The action is that engine blasting a massive amount of air backward at incredible speed.
And the reaction? You guessed it. All that air moving backward pushes the engine and the whole plane forward. That powerful forward push is what we call thrust. It is literally the exact same idea as our little balloon rocket, just with, a bit more oomph. Once you see it, you start seeing it everywhere. A boat's propeller? It's pushing water back to go forward. A real rocket engine? It's firing hot gas down to go up. The rule is always the same. If you want to go one way, you've got to push something in the opposite direction. So, what's the big takeaway here? It's that we can't just move. It's impossible. To go anywhere, we have to push on something else. We're always interacting with our surroundings, the ground, the water, the air. It's like a constant dance of pushes and pulls. So, I'll leave you with this little mind bender. Think about it. Right now, wherever you are, you're pushing down on something. Maybe it's a chair, maybe it's the floor. That's your action. So, if Newton's right, what's the equal and opposite reaction? What invisible force is pushing back up on you at this very moment? Kind of changes how you see things, doesn't it?